Hello everybody, my name is Hanno van Raat. I'm product manager for Moldflow. We are here today to launch our Moldflow 2017 R2 release. With the switch from a perpetual license model to a term-based license model, we actually have a bit more freedom in how frequently we deliver our software and new functionality. And you may or may not have heard this, but we are moving to a quarterly release schedule right now, which means that every quarter we will be producing a new version of Moldflow, of a Moldflow product, and with new functionality baked into that. So, so we came out of the 27 FCS release, had a lot of functionality we provided in that release, and in the last couple of months we've had 2 service specs come out to sort of complete some of the features that were needed a bit more work. But in the 2017 R2 release we have actually a lot of new functionality brought into the software this year. So I'm going to talk a little bit about an advisor repackaging. We have some really exciting developments that we did for the geometry modification, and starting to look at parametric optimization for that. Some improvements in the job manager that we added this time around. We added a new functionality for 3D RTM and SRIM. We made some solver improvements and some other enhancements along the lines of bug fixes. So this is a high-level overview of some of the things that we've done in this release, but I will step through them in a bit more detailed way. So we repackaged our advisor product line a little bit more. We went from a 3-product line SKU to sort of the 3-product line product to 2 products. So and we packaged them up along the lines of functionality that a user persona would be looking for. So we have identified two user personas. One is the part designer, somebody that spends his life primarily in the CAD software, is not necessarily a manufacturing expert or doesn't know necessarily all that much about plastics, but makes a lot of decisions about like that determine the quality of the plastic part that's come off a machine. And then we have the mold designer or / tooling engineer, as somebody that's more familiar with the manufacturing process, that has a bit more understanding of the molding process itself and plastics, and but still not a full-time, let's say, expert. That person might spend a little bit more time on, like maybe 25% of his time on using Moldflow, if that. But occasionally it will be used as a viable tool to make some good decisions on like where to place my put the gate, how to lay out my cavities and such. So we went again from sort of 3 advisor products to 2 advisor products. Now we end up with Advisor Premium, which is effectively the exact same product that we had for Advisor Standard in the past, but we added the 3D capabilities into that. So that basically means you can now run all models on a Advisor Premium license. Customers will automatically be migrated to this new license. And then we have the Advisor Ultimate, which is effectively the exact same product as the Advisor Ultimate in the past, which includes runner balancing, cavity layout, and all that more mold-related stuff, including cooling as well as fiber orientation and warpage. So again, it's been repackaged for 2 different user personas. They're very, very clearly embarked, sort of separated off from each other. So there's like clear demarcation between what an advisor and designer would be looking for versus somebody who's more like in the mold layout and in the quality of of a plastic part itself and the manufacturing process. So what we did is also include Moldflow design into the product. In both products, and then it was already available as part of the advisor license, but it's now also included fully in the installer. So that basically means if you install Advisor, you will also including with that and install Moldflow design as an option. So Moldflow Design is a tool that lives inside of the CAD environment, where a designer or somebody that uses SolidWorks, Creo, or Inventor can make design modifications in sort of their CAD environment, and we get really quick updates on the quality of the plastic part that's being designed. If you want to learn a bit more, we have a new functionality that we developed was specifically for a launcher button that sits in the CAD environment, particularly Inventor, Creo, SolidWorks, and Siemens NX, where when the designer thinks he's done, he wants to do it more, he clicks the launcher button. That will open up Moldflow Advisor with that part in it. So we now create a project. The model is automatically imported and ready for analysis. So effectively with this, the Advisor product becomes more a two-mode product, if you will. So one is the Moldflow design piece that lives inside of the CAD environment while you are designing, sort of to get you into get the product design into a space where it's a good quality plastic product. And when you want to do a little more actual analysis work, you export the part and model automatically to the Advisor product line itself, where the model gets imported automatically. So two modes, one more. So while you're designing, and one more, like, let me try to find out what's things in a bit more detail, sort of a bit more analysis work. There's another way to look at it, sort of where the different pieces of functionality fall. So the Advisor Premium is, again, it's more the designer-friendly products. It's Moldflow Design, filling, weld lines, sync marks, dual domain mesh, and 3D mesh. And it has the now push to from CAD button in the launcher in the CAD environment, and the exact same functionality that is available for the Advisor Premium users, plus runner balancing, multi-cavity, runner design, cooling channels, warpage, packing, and fiber orientation. So. That gets us to the next topic, and this is primarily for the Insight product line, but it is actually something that we've been working on for a very long time, for a very long time, and it's actually like something that's fairly hard to do, actually. So most of the models that get read into Moldflow are coming from like third-party CAD systems like SolidWorks, Creo, CATIA, etc., etc. And as soon as you bring those CAD models into another environment like Moldflow Insight, you actually lose access to the feature trees, which makes it really hard to still make design modifications to this part. So you have other parametric free modelers on the market, like including in Inventor Fusion, but there's still like some really hard problems out there in terms of, let's say you bring a model that has a bunch of fillets and you want to move a face that's attached to a fillet. There's a good chance that the parametric free modeler does not really know how to deal with the fillet. You want to morph that fillet, or you want to preserve the shape of that fillet. So in the new release of Moldflow 2017 R2, we made a very, very big breakthrough. We have now the capability to select a face. In this particular case, I've selected a top face of this model over here, and I can have new tools available under the geometry, CAD modify CAD surfaces. I can make changes to that CAD surface in using the local normal direction, or basically doing vector operations, move things. You also have, you can specify automatically detect either fillets or chamfer faces, and determine whether you want to preserve those faces and fillets, or you want to morph those. So in this case, I selected preserve the fillets. So every time I transform a face, the attached fillets that are attached to this particular surface will automatically translate with it. And then I can specify how much of a deformation I make over here. So in this case, I specified 5 millimeters, which is a bit excessive, but more than you would typically expect to do. This is meant to to make small tweaks to a model, not necessarily to really build a completely new model form, but just to give you an idea sort of what's possible here. We also have a preview mode, so before we actually apply the deformation, we can have a quick look and see if there's actually going to be a valid transformation, yes or no. Let's say if you were to say, I want to move a face by, let's say, 5 millimeters, and that would cause a clash with another surface. That would be an invalid transformation, so you would notice ahead of time before you start applying the deformation. So to give you a quick example, I took a model that some of you may have seen as this is a slightly modified Moldflow classic model, a demo model, the P-type. I selected a number of faces on the interior and basically made a vector operation on this. So that made that particular face move here. Then I selected the interior surface of this boss over here, and made a normal operation on that for 1.5 millimeters. Then I selected the exterior face and selected the fillets as another area that we have to preserve, and do a normal operation for minus 1.5 millimeters. So now we end up with like the boss of the same wall thickness as in initial things, but just with a smaller diameter. And then I just picked up the funky hole over here and gave it a vector operation and moved it to the other side of the part. And then I took some of the top faces of the model and gave it a normal direction of minus 10 millimeters. So I end up with a very heavily modified part compared to the original model, right? So this would be a bit more extreme than you would typically do, but like the intent is basically to deliver a set of tools that allow you to make to impact things like wall thicknesses or position of ribs or small positions of certain features. The other thing that's worth pointing out is like I do the operation not on one particular face, but on a group of faces. So in this particular case, I have a group of faces that I selected. In this particular case, again, I have a number of 3 different set of faces that I selected to do the operation on. And in this particular case over here, I have a very fairly complex set of faces that I do the operation on. So, but if I go back 2 slides over here, I have another option here in the dialog, and it says Save CAD Modification. And this is actually an option that I can use to drive these type of modifications through a parametric study. So I can, instead of applying the deformation straight away manually and basically seeing the result directly, I can save this group, this selection that I made as a parameter. And this parameter, I can actually, like I said, I can save this parameter and give it a name. And when I go to my parametric study builder, which is a variation of our design of experiments builder, I can start giving that a set of deformations. So instead of just looking at one variation that I made manually, I can now, in this particular case, select this particular set of faces that I want to modify, and I give 4 different modifications to it. So I create 4 different permutations of this this model now. I can do this for several faces, and I can basically create like all the permutations of, let's say, 2 or 3 different combinations of modification that I selected. I can run my parametric study at that point, and one thing that's important, so I can, the first thing I will do is look at my results compare and get a quick overview of sort of what the outcomes of my analysis variations are going to be. I can make some first selection of which models are going to be in good shape, which meet my criteria. Let's say I'm interested in having the part fill first of all. In this particular case, the first 2 variations that I created did not fill, so they're not suitable for. But I can also look at things like look at the pressure has to be below a specific threshold. injection pressure, or the clamp force has to be below a certain threshold, and I can make selections on the basis of that, and then I can select the different variations that I would like to explore further, import them in my study file in my project, and explore the different options like I would normally interrogate, let's say, 2 or 3 different models manually. So this is a very, very powerful thing. We can actually now really look at like how thin can I make this part, or if I make my if I make changes to my thickness of my part or move a rib, what are the implications on warpage, for instance? Right. So very powerful. Also, like you can actually look at how thin can I make this part? It still fills. It still is going to be a viable plastic part at the same time, but with a reduced cycle time, because I made my part thinner, for instance, and at that point I can reduce cycle time and therefore save a lot of cost. So we also made some improvements to the job manager. So first of all, we made some improvements in the core stability of the product. So overall, we see a drastic improvement in the success rate of the job manager transferring the results back. We also have now support for proxy networks. So in previous releases, if you had a proxy network, then the job manager could not work, it would not function. So we were able to replicate a proxy setup internally, and also work with a number of customers that experienced problems with the proxy settings, and we're confirming that the resolution actually works for them really well. We added some new some better logging in the SGM, so now can actually, when there's problems occurring, we have a bit more information to diagnose sort of where the problems are coming from, as well as we have now a progress bar for Linux. So in the prior release, when you run an analysis on Linux, the progress bar was not showing for Linux jobs. But we did not only improve the overall stability, but also looked at sort of usability of the job manager, particularly in the areas of the batch queue. The batch queue was a little bit hidden in the past, and now it's actually a lot more easy to detect and control. So we can have clear within the user interface, like how to start a batch queue and a pause option, and you can add new servers in it very, very quickly. So a lot better control. And another something that a number of our customers asked for was the ability to check the load on a remote server. So until now, it was impossible to see. Look on a server and see what other Moldflow jobs are running on this particular job server. So now we have the ability to select a server from the list and then hit the server load and basically see what's running on that machine and where the jobs are coming from. So overall, good improvement on the job manager. It's been very encouraging. The team has worked on it diligently and has used it for like several weeks on it without any problems on our end. So we made good progress there. So we added 3D RTM to the product as well. So support for the resin transfer molding process in 3D. For those who are not familiar with resin transfer molding, you basically start off with a set of fiber mats, continuous fiber composite mats typically, that you place in the mold. You either through a draping operation or a forming operation conform the part to a shape. The deformation of this the fabric that you lay into the mold at that point will determine the permeability of changes of how the resin will flow through this dry fiber, and this is something that actually is like a property of the fiber mat itself. So to test that, typically is a very simple test to see how how the anisotropy of the permeability actually works. So you basically have a fiber mat, and you put a circular shaped sort of resin inlet, and basically let the resin penetrate the fabric, and you typically see like more like an oval shaped flow pattern. And these aspect ratios, like measurements, you can make, and they can help you identify sort of how anisotropic the permeability of how the resin will flow through the fabric. So if it were completely isotropic, coming out of a circular shaped injection resin hole, inlet hole, you would also expect to have a circular shaped flow pattern. But in case of a fiber mat, you typically, the weave of the fiber will basically create an anisotropic permeability. So the resin will flow through it in an oval shape. So those properties can be derived from the original fiber mat, and we have a tool that's actually very neat. You can start with a sort of laying the fiber mats following fully the contours of the part. So when we define the orientation of the fiber mat, we have an option to specify like follow the contours of the part. So the permeability along this axis will be continuously the same, even though it actually curves, right? So it's a three-dimensional shape, but the orientation of the fiber mat will continue to follow the contours of it, and the permeability will be accounted for properly there. So the only thing it does not do at the moment is like a true forming operation. So if with the forming, the shaping of the dry fiber mat, you change the orientation of the weave, or the local permeability of the weave at that point, those type of effects are not taken into account just yet. But there are ways to build an interface between, let's say, the true forming solution like PEM RTM, or PEM form, or things you can do with LS-DYNA to bring those results into the conclusions from the material orientation into the RTM solution, and properly account for this, because the permeability is now an element property, and you can basically give every element in this part a different permeability. So when you know what these are, through another draping code, you can actually orient apply the right properties. I see there's some questions popping up, but I will take those later on in the presentation. Some other solver improvements we made is that we actually spent a lot of time in the last couple of months to improve the 3D fiber orientation code. We were seeing some issues with sort of the default Volcker-Tucker model, where we were not able to predict sort of we were over predicting the skin orientation to a great extent, and we were under predicting the amount of orientation in the core, which is actually, in some cases, actually perpendicular to the flow direction. So the reorientation of the fibers, we were not very effective in actually capturing those effects in some cases. We have developed a new fiber orientation modules model that we call the MRD model, Moldflow Rotationally Diffusion Model. That's now actually able to really do a good job in both capturing the effects of at the skin, as well as at the core layer. So we see the fiber orientation tensor going below 0.5. In the experimental side, we go to, let's say, like almost 0.1, so almost a pure transverse orientation. We are not quite that far, but actually very close with the new MRD model. We also made some improvements with the default values for the RC module, and added a new closure model to work with the new fiber orientation models. So overall, very, very good improvement with the in the fiber orientation for 3D. We also introduced a new stress space warpage prediction. So in the past we were in 3D warp we were running the deriving the warpage from volumetric shrinkage prediction that was distributed. Now we actually are using the residual stresses that are building up in the plastic part, which is sort of similar to what the scheme that we're using for the for midplane and dual domain in the uncorrected residual stress. So we're trying to narrow, basically reduce the differences between the two different code bases and make sure that the results are getting very similar. So we did a very good job at that, and we're seeing some really good improvements coming out of this particular release. And this particular development is a foundational piece that we need to do to make progress in other areas that we want to move into that were not possible with the prior warpage scheme. So as a side effect, we also have some new results: pressure at freeze, stress tensor warp after deformation, strain tensor warp after deformation, maximum shear stress, and the Mises-Henke stress after deformation. So post-molding stress stresses now can also be displayed. Another thing that we added this quarter was the ability to include wall slip. So we've had wall slip as an option in the 3D flow solver for a number of years. The first couple of years we were not very happy with the. It was a very simple scheme, and we didn't. There were some limitations that we thought it was a free slip scheme, and in reality, at some points, like even though you have slip, it will not be free slip. There will be some friction built into the system that will cause material to stick. So we have some new coefficients that we added to this model, and it's now for the first time available in a commercial release. So two more things we added to the cool solver. One is the ability to change the flow rate of coolant material through the through an injection molding cycle. So if you want to heat up the molds before you start injecting the the plastic, you want to heat up the mold as much as you can to maybe get a high quality surface finish. To that effect, we can actually just stop the flow rate, the coolant from flowing through the channels. If there's no flow rate through the channels, there's no cooling provided to the mold. Therefore, the mold will locally heat up temporarily. But as soon as you want the part is filled, you can start running water through the channels again, or other coolant media through the channels again to reduce the temperature of the mold and bring the part to cool down. So this can be controlled by time and thermocouple. Another thing that we added to the cool solution was the ability to, we made some improvements in the way we set up heating elements or heater bands in Moldflow. Until now we had to specify a heat flux, and heat flux is not something that's really typically provided as something that's you find on these heater bands or heating elements, but they are have what they call a heater rating. So now actually that becomes input to our cooling solution as well. So just an easier way to set up the solver and bring it more in line with what people actually have access to in reality. Some other enhancements, and some of these have been available in Service Pack 2 as well. But first, we've not really reported on these very much. But you have now in the options, in the results options, you have the ability to change the fonts style as well as the font size. So in case you want to increase the font size in the results, we have now an option to provide it to you. So that was a very frequently requested enhancement. Another one that's been around for a very, very long time is the ability to preserve the consistency between valve gate trigger nodes and if you do a remeshing. So in the past, if you had specified, let's say, this node over here as a valve gate trigger, and you did a remeshing of the part, and the node number would have been moved here, the node's number 655 would have moved here, this would effectively have become the trigger node, and it would not be possible for you to see actually that anything had changed. So now we actually have changed this quite a bit, and we have now, so if the renumber is happening, this node over here will now become, let's say, 722, then in the valve gate controller we will now call that number 722. So the consistency will be preserved. So this is another thing that has been requested very often, and it was actually very high on the idea station as well. So we added some new videos in the training material and the help documentation. So particularly around meshing, mesh generation, and such. So I think some really good tips in there worth looking into. And another enhancement request that we got in the last couple of years was the ability to, in the mesh statistics, put all the mesh statistics back into a panel. We used to have this in the past. In the last couple of releases, this was moved into the dialog itself, which was uncomfortable because there's not much real estate there. But now we have an option to open this model back up into a dialog. Other than that, we fixed a number of bugs. We found that it was a bug in the ribbon component that we get from Autodesk that caused a black box appear in Windows 10 sometimes, which made that product at that point unusable. So that was resolved. We are now able to capture simultaneous animations into an AVI file. Advanced material exchange, like there's some component consolidation, that's something that you're not going to notice that much. The data fitting tool has been updated. Some fixes to the licensing itself, some localization language issues have been resolved, and we updated the CAD import versions to the latest CATIA available versions and Parasolid. And on Linux, we improved the installation and uninstallation significantly. The memory has been greatly reduced, memory usage. The solver is more stable. We have less issues with crashes, and we have some improvements in the job manager there as well. So I think with that, I'm at the end of the presentation, and I think there are quite a few questions that have come up. All right. So I'll see how far we can go in the remaining 25 minutes. The first question is, when will Moldflow Insight Premium become Ultimate? I think Kristen handled that one. So repackaging, so first of all, we cannot announce them ahead of time. But secondly, at the moment, I don't see a great need to separate the inside packaging out as much. Jim McGuire asks, can the improved job manager detect earlier versions of Moldflow running? So it basically will. If this is related to installation, yes, it will. It will automatically uninstall prior versions of it, and considering this is a shared component between sort of the 2017 release of Moldflow, let's say 2017 FCS release of Moldflow, and 2017 R2, for instance, you would be able to see in the same job manager the different versions. If you were to submit something from a 2017 UI and a 2017 R2 UI, you would see them both in the same job manager. Which fiber orientation is best for warpage then? Standard. The default at the moment is for 3D for the 3D module is right now the MRD model. We run a fairly extensive regression test as well, to make sure that we understand the behavior properly, as well as run it against known data sets that we have. And we see that the MRD model is getting slightly better results than the new RC model. So we moved away from the Volker-Tucker model as a default, and now it's MRD. Is it possible to analyze nanofiber, nanotubes, particles, infused polymer in Moldflow? I would think so. At the same time, I don't think I have a great deal of experience with this particular, what the limitation would be, but in principle, the same laws of physics would apply to nanoparticles, I would have to assume. There may be some tuning that needs to be made to make it more compatible, so to tune it for nanoparticles, but at the moment I have no direct guidelines here for this. Only plastic slip or also rubber? I will have to look into that. I believe it is both for the thermoset and the thermoplastic, but I will have to check that. I know for a fact that it's not yet enabled for work that we're working on for metal injection molding or metal powder injection molding. Can 2017 R2 be installed in parallel to 2017? Yes. So that's a very, very good question, and thank you for bringing it up, because that is an important piece. Going forward, every quarterly release will install side by side. So that basically means that if next quarter we would be releasing 2017.3, that would install next to 2017 FCS and next to a 2017 R2. So going forward, we will. So this has a benefit to you that you actually can, you can continue working on projects you already started on, let's say 2017 FCS, and wind those down. And new projects that you start, you might want to start with sort of the latest version. So it makes the transition from out of a version and into another version a little bit easier, I would say. Can thermocouple control cooling be used to control heating elements? For example, start heating with heating elements, then the temperature goes below a set point, then cool when it goes up a certain temperature, or is it limited control only to coolant flow rate? The thermocouple control, thermocouples can also be controlled by heating elements. Sorry, it can also control heating elements. That have already been there for a while, I believe. And then Dankeschön von Harald. When will be available to release number 2? The R2 release is scheduled for at the moment to go live mid-October. So it's still like, I'd say, a week and a half away. We are at the moment doing the last very final QA on it. So it should become available very soon. Keep an eye out on the discussion forums. So I will announce the availability. The intent is to launch it at the same time as the K show. So, do you know if we're now able to use DOE feature in the updates? In the new update, as we have been unable to use this feature in 2017. It was previously working on 2016 version. I believe this is related to a bug on in warpage results not coming back. I believe that has been resolved, if that's correct. So the deal otherwise the deal was working outside of this particular bug that was had been there. What type of CAD files are you able to save with the direct geometry modification tool? This would be, at the moment, it's limited to SAT, but we are looking at adding the step files into a future release. We have all the other formats available, but we started with SAT at the moment. IGES we will probably not do. IGES tends to be a very poor format, just want to say. And I think that's the last question that I had in my list. If there are no more questions, I'll give everybody another 30 seconds. And if there are no more questions coming in, then I want to thank everybody. Will the presentation be available later? Yes. Actually, this will be recorded and maybe published on YouTube. If there are no more questions, then thanks everybody for attending. I hope you're going to be at the K-Show. If you are going to go to the K-Show this year, please make sure that you stop by our booth. We are going to be in Hall 11. If you want to know exactly or make an appointment, so we can make an appointment through MF Software or direct. If you want to know exactly where we're going to be, just shoot me an email and I can send you exactly where we're going to be. Booth number. Give me a second. It's in my signature, so I'll pull up an email that I sent out. Mail, new. We are going to be at Hall 11, G73. That's correct, yeah. Good. All right, I hope to see you guys at the K-Show. It's going to be an exciting time. I'm always interested in see what's happening in the industry. So hope to see you there. And if not, have a great rest of the week. Bye-bye.